Okay, well, cool. Well, welcome. We're Triad Microsoft User Group in Greensboro, but we've been virtual for like everybody else last 2 years. So it's glad to see folks from different cities joining us. We are underneath the Azure data community. So those two links down below, you can see all the other communities that are a part of the data groups and all their meetups. So highly recommend you check them out. A lot of the folks will record and you can see what upcoming sessions there are. So it's a great resource. SQL Saturdays are starting to slowly pop up. So if you happen to be in Haiti, well, good for you. In April, you're all set. And Colorado Springs and Jacksonville. So those are coming up. And then a few other conferences coming up. We've got SQL Bits coming up, actually. Are you headed out to that, Kevin?
I am not. I'm staying here. I may be going to Jacksonville. We'll find out.
Okay, cool. And then a few others. So Data Saturdays are also happening. Most of those are out of the country, but yeah, so you just, and this is all on SQLSaturday.com. It's nice they link to these as well. Other conferences, there's a few recordings here. So there was a really large cloud summit back in 2021 in the fall. Azure Focus, there's a ton of recordings. Data Minutes was just a little while ago. The recording link is there. There's a Azure AI conference in Las Vegas. And then if you're curious on other future events, Azure events and the virtual training days are really nice as well. If you want to get a quick overview of some of their technologies, they do a good job on those. If for those of you that used to be under the PASS umbrella, all their material is located on PASS TV on YouTube. So all the conference materials are there. So a lot of this stuff still works for the sort of a lot of the engines, that kind of stuff. So a lot of good resources there. We have a YouTube channel. We're not special enough to have our own vanity URL yet, but we try to record all of our sessions and throw them out there. So just search for Triad Data Platform User Group and you'll find our recordings there. And what used to be the PASS Pro membership is now underneath the Redgate University Hub, called the Educational Series. And there's 4 courses there and there's some good material there if you're curious. So check those out. They kept all those recordings as well. And with that, I will pass over to Kevin. He's going to take us to the serverless area of Synapse. So let me stop sharing and you're all set.
All right. There we go. Let's do this. So I will have chat right in front of me the whole time, which means actually my slides are over here. I'm going to be looking that way quite a bit. But I'll try to look chat in the eye when I respond. So welcome everybody to where we're going. We don't need servers. This is the Serverless SQL Pool in Azure Synapse Analytics. My name is Kevin Feasel. I am a data platform MVP out of Durham, North Carolina, where I run a predictive analytics team and do a couple of other things too. I also have a blog called Curated SQL, where I try to find and link to 5 to 10 posts per day on topics all across the data platform space. Check that out, curatedsql.com. What I'd like to do in this talk is first give you an idea of what Azure Synapse Analytics is, what the different pools are, and then understand where the Serverless SQL Pool fits in. We're going to see how to load data into the Serverless SQL Pool, how to query data from it, and get a feeling for how expensive this whole thing's going to be. And if you have any questions, feel free to cut me off and ask at any point or put messages in chat and I would definitely will see them. So let's start with a quick overview. Azure Synapse Analytics is Microsoft's solution for modern data warehousing, and it is made up of 4 major pools. The first pool is called the Dedicated SQL Pool. The idea here is this used to be called Azure SQL Data Warehouse, and on premises, it started out as Parallel Data Warehouse Edition of SQL Server, moved to APS. It is a massive parallel processing version of SQL Server. It is a variant, not exactly the same as on-prem SQL Server, definitely not exactly the same as Azure SQL Database. It is intended to work with data warehousing scenarios. I have a Kimball style model with facts and dimensions, and I have a lot of data. Their recommendation is minimum 1 terabyte for this to work well. That's kind of you must be this tall to ride the ride. You can create a dedicated SQL pool and put in 20 kilobytes of data. You're probably going to be spending way too much money for that, though. They generally recommend you want to have at least about 1 billion records in your largest fact table before this really takes off. But the big thing about it is that users typically work off of a set number of queries. Think of this as your regular reporting. I have regulatory requirements. I have daily, monthly, annual reports that different parts of the organization come up with. I have these reports, these requests that the where clauses may not be exactly the same. I may filter on different things at different times, but I'm usually querying the same sets of data in similar ways. Spark pools, completely different version. This is built off of Apache Spark. Apache Spark is another distributed computing platform, and it's built in the Hadoop ecosystem. Spark clusters are a great way of doing complicated data transformation that you really don't want to trust to T-SQL. Dedicated SQL pools, by the way, use almost entirely the same T-SQL that you know on premises. But Spark pools are going to let you use Python, use Scala, use Java to write code to transform data. What that means is that I could actually combine these concepts and have data in one pool, process it using a different pool, and write it back to a pool. This allows me to implement, say, distributed machine learning tasks that I may retrieve data out of that dedicated SQL pool, process it using scikit-learn in Python, and then build a model, train that model, and serve it off of Azure Kubernetes service, or serve it actually from Azure Synapse Analytics if necessary. We can also take data that is running from on-premises Spark clusters or from HD Insight, if you're using that, and migrate it to Synapse. Now, I would recommend that if you're using Azure Databricks and you're really happy with Databricks, you just stay with Databricks. Databricks is generally better than Azure Synapse Analytics Spark pools. They're working on it. They're making Spark pools an improved experience from where it was even a few months ago. But I would say in a lot of cases, if you're comfortable with Databricks, stay there. So now let's talk about the third type of pool, the serverless SQL pool. And to explain this, I'm going to compare it to dedicated pools. The dedicated pool, warehousing, fixed reporting purposes. The serverless pool, going to be a little different because they don't actually store data. There's no server hosting your files. Instead, they read files from your data lake, which actually is the same as what the Spark pool does. The Spark pools don't actually store your data. A data lake stores your data. The serverless SQL pool reads that data and lets you query it using T-SQL. Serverless SQL pool is going to require no infrastructure or resource reservation. There are no upfront costs. You may have a serverless SQL pool available to you 100% of the time, not pay a dime for it until you write queries against it. Then the pricing model becomes $5 per terabyte of data processed. And we'll talk about what a terabyte of data processed means in about 55 minutes or so. The main case for the serverless SQL pool is ad hoc exploration of your data in a data lake, or I like to call it data spelunking. You're looking around and aren't quite ready to commit to putting it in a real warehouse, but you need to investigate. That's where that serverless SQL pool really makes sense, because the dedicated SQL pool if you think about the flow of loading data into a warehouse, if I'm a data scientist and I say, hey, I think it would be really useful to have this attribute, this feature available to me. And so the warehousing team looks, figures out where it is in the source system. They build ETL processes. They have to clean the data. They have to figure out where it fits in the model. They have to do all of the processing work to change the warehouse. They have to change the ETL processes. They have to do all of the testing. And maybe that takes them 6 weeks, 8 weeks, 12 weeks. And then data scientist looks and says, oh, there's no correlation here. Oh, well. And generally what happens is that data scientist never tells the warehousing team because, well, they just spent 12 weeks putting this together. If I tell them that I don't actually need it, they're going to get upset and not help me the next time that I need it. So instead, that attribute lingers. We're spending time pulling that data in that nobody ever uses because it turns out it wasn't useful. By contrast, the serverless example is a lot simpler because we have that data, it's just in files. And data scientist person or a data engineer can look at that file, parse it, figure out what it is, what it's like, say, oh, there's no correlation. And all right, no problem. The last type of pool, Data Explorer pools. Data Explorer pools are going to let you perform real-time analysis and time series analysis on large amounts of data. Historically, this has been log data, but it doesn't have to be logs. Generally, anything that's time series works really well in this. The language you use to query it is the Kusto query language, KQL. That may be familiar to you from Azure Data Explorer. KQL is a lot like Splunk's querying language. And if you're familiar with that, you'll be pretty up to date with this. That said, Data Explorer pools are a preview feature. I'm not going to talk about them again. I just wanted to mention that they exist. So, okay, how do I create a serverless SQL pool? Pretty easy, actually. Turns out you don't create one at all. It's created for you. When you create a new Azure Synapse Analytics workspace, it's going to come with a built-in serverless SQL pool right there for you. It's even called built-in. And what if you want to create a second one? No dice. If you click new, that's going to create a new Data Explorer, or excuse me, a new dedicated SQL pool. So not going to let you create a new serverless SQL pool. All right, well, what if I want to delete it? No dice. You cannot delete the serverless SQL pool. Cannot create a second one. Cannot modify the existing one in sense of renaming it or anything. Cannot delete it. It simply exists. It exists with your workspace. It will exist for the life of your workspace. But remember,
that's what I was just about to ask. How do I know what it covers? It covers everything in that workspace, Kevin?
So the serverless SQL pool is its own set of functionality that lives within my broader Azure Synapse Analytics workspace. So within that broader workspace, I can have a dedicated SQL pool. I could have multiple Spark pools. I could have Data Explorer pools, and I have that one serverless SQL pool.
So how do I know it was created automatically for me? How do I know? And maybe this is a naive question, but hey, there's only 4 of us. So how do I know what all it covers within my workspace?
We're going to see.
A naive question?
No. So my short answer is we're going to see. We're going to populate it.
Okay.
And
I'll wait and see. Okay, good enough.
Fair enough. And if I don't get to, if you want more clarification, we'll do that.
Fair enough.
And one thing I wanted to highlight that you mentioned, Kevin, was, and we ran into this actually just yesterday, was we were playing with the lake databases and ran into some issues with the schema being generated automatically within our tables, where within Databricks, it works like a champ. And so, like you said, I think Databricks is ahead of the game right now, and there's some growing pains or just slow growing with the lake databases right now.
Yeah. Lake databases, by the way, are a different type of data model that we're not really going to dive into much today. They're related. Basically, I can create a lake database that exposes Hive metadata to allow the serverless SQL pool and a Spark pool to query the same data in our data lake. And that's a neat concept, but yeah, it is still pretty new in the Synapse world. You're right that the Databricks world has a bit more maturity around that concept, but I'd say give it 3 to 6 months. Hopefully we'll see more rounds of improvement around it.
Yeah, that's what we're hoping.
So, all right. You have that one serverless SQL pool. It is simply there. But if you don't use it, if you don't query against it, you're never charged for it. So no pricing, no problem with pricing. So how do we query data against it? Especially given that we can't really insert data. We'll talk about that. Let's talk about the data that we're going to insert. Our scenario. We are with the Martian Agricultural Data Collection and Ownership Combine. And so we work for Mad Cow. That's right.
Nice.
We're collecting sensor data from terraforming operations on Mars, and this is 100 years in the future. We want to figure out what plots are best suited for particular crops. And we've collected a lot of IoT data from different plots of data across our cities on Mars. And we're using Azure Synapse Analytics for the job because 100 years from now, they'll have figured out lake databases. So what language do we use? Well, Serverless SQL Pool uses T-SQL. It is almost entirely the same T-SQL that we know and hopefully love on premises. I say almost because, well, the Serverless SQL Pool is almost entirely read-only. It turns out that you can't insert, update, delete, merge, truncate data in a Serverless SQL Pool. There's no server to store those inserted, updated, deleted, merged, truncated records. What we do instead is we load the data from our data lake and make it available, expose it in our Serverless SQL Pool. So the Serverless SQL Pool is on-demand compute that uses the data lake as underlying storage. And every Azure Synapse Analytics workspace is going to have a data lake storage account associated with it. It's one of the prerequisites for creating that workspace. So the Serverless SQL Pool already has permission to access that storage account, unless you do a really bad job of breaking everything, in which case you may have to start over again. So how do we query this data? It turns out there are two ways. The first method I'm going to talk about is called Open Rowset. Open Rowset, you may be familiar with the idea on premises because that's a command on-prem as well. But here, what we're doing is we're saying, all right, I'm going to take data from some file. I'm going to bulk load data from errorability score /errorability score _1.txt. It's a CSV file, and it's actually technically semicolon delimited, not comma delimited. So shout out to the Germans. The first row there is 1. I don't have any headers. That's what that's saying. And then I say I have a with clause, and I can optionally include this with clause where I specify what are the names of those columns. So if I have headers, we'll use those headers. But I don't have headers, so I'm going to specify plot ID, report date time, errorability score. I'm going to call this virtual table errorability, and I can select top 10 star from it and get 10 rows. Now, Open Rowset itself supports a few different data types. CSV, or really delimited files. I just showed you an example of that. Parquet, Json, and Delta Lake, which is a fairly new format. So Parquet files, really good for columnar data storage. Think column store indexes in SQL Server. That kind of data where it's, say, there's a lot of information, there's a lot of rows of data, and we tend to query 1 or 2 columns, and we tend to write aggregate statements against those columns. Parquet tends to be very efficient for that. We can read JSON data, though there's a bit of a little bit of about that. And we can read from the Delta Lake. The Delta Lake originally was invented by the folks at Databricks as a way of, how do I update the data lake? How do I have almost transactional style work within a data lake? And basically, it's a combination of Parquet and JSON files. So since Databricks released that, they actually opened it up to the Linux Foundation. They gifted it to them. Now, Delta Lake is a broad community standard. Databricks has their own special flourishes, but there is an open source, publicly available version of Delta Lake as well that Azure Synapse Analytics uses. This allows for serializable transactions. So I can have an insert statement of one row and insert into one table, insert into a second table. If the second insert fails, I can roll back both of them. We have the notion of time travel. Think temporal tables in SQL Server. I can view the history of a record and actually revert rows. I can go back to a prior version. We can have schema enforcement using Parquet. One of the niceties of Parquet, in addition to its really efficient columnar operation, is that it names columns. So unlike a CSV, where maybe you have headers, maybe you don't, Parquet has a header section that tells you I have 12 columns. These are the names of the columns. These are the data types of the columns. This is how many rows are in the file. This is how many blanks there are. It's going to tell you that information when you build the Parquet file. And Delta Lake also, at least in the Spark world, in Databricks, will allow you to insert, update, delete, and merge data. In Azure Synapse Analytics, especially the Serverless SQL Pool, in the Serverless SQL Pool, you're not inserting, updating, deleting, merging. In Spark pools, yes, you can do that. So let's go to a demo. I already have a Synapse workspace up and available, and I've got a few scripts. We're going to check out some data. So I need to, there we go. I have a Serverless SQL Pool because everybody's got one, and also a dedicated SQL pool that is turned off because it costs a lot of money to turn that thing on. So let's let's actually make sure we have a database.
We're in here, Kevin. Now I'm going to say, can I figure out the scope of this thing now that we're in your serverless pool?
I do hope so, and if not, then I'll help you. I'll help you with an answer. So where am I looking? I am struggling to find the database because that's actually my dedicated SQL pool. That's my Data Explorer pool, and I should have my Serverless SQL pool in the workspace data. So let me see what's going on here. We're going to run this. We're going to use the database Mars Farming. We're going to just run this query and full send it. It's going to retrieve 10 rows from this file right here. And you're noticing it's taking a few seconds. The Serverless SQL pool usually is faster than that, but it's shy during demos. However, it will never be fast. It's never going to be really zippy because at the end of the day, it's reading text files, processing text files, and displaying data as result sets for you. So it's very interesting. It's just probably not going to be fast. I have this file here. Let's see if we can discern where it came from, what it looks like. And here is my data lake that I've got set up. I've got a Mars Farming. So we can see the container is Synapse. I've got a Mars Farming container as well, but let's go to Synapse. And inside here, Mars Farming raw, arability score. And we have 9,300 or so files that represent different plots. I can preview this data and we can see that it is in fact semicolon delimited data set that includes the plot ID, the date and time of our data collection, and the errability score in this case, which ranges from roughly 0 to 1. And I collect this data every 10 minutes, and I did so over the course of 5 years for 9,000 plots. There's a fair amount of data in here. So my end result gives me plots, report dates and time, errability scores. Not too bad. That data doesn't live in the serverless SQL pool. It lives in the data lake in that location. It's just that we can query it from our serverless SQL pool. So another query, what if I want to get the distinct set of years? What I'm getting at in this query is the syntax that we're using, that T-SQL that we're writing, is basically just normal T-SQL. There's nothing incredibly special about it. So we can see that I've got data from 2116 to 2120, and it read from that one file. But what if I want to read from more than one file? What if I want to read from a bunch of files? This time, I'm looking at the curated folder. So if I pop back up here to Synapse, I have a curated folder that has errability score, and it actually breaks down by year and then month. And because these are relatively small data sets for year and month, it's going to give me the data for the entire year and month as a series of Parquet files that I created. Each one of these Parquet files is itself actually pretty small. I've got 43 of them. It's probably somewhere in the order of about 20 megabytes. But if it was CSVs, probably closer on the order of about 200 megabytes. Pretty good compression ratio. Whoops. If I wanted to read through these and see all of 2117, I can use this asterisk to say all months within there, and then all Parquet files within there. And we can find what is the max errability score. And what it's going to do is it'll look inside errability score. It'll say, oh, I chose 2117. And then I said star. So all of the subdirectories, all of the files in there, it's going to read all of those files and will then perform whatever T-SQL operation I need to do with that data and get the max errability score, which is slightly above 1. Took 22 seconds to do that. Again, it's not going to be a speed demon, but it did read the files in the data lake without me having to think about formatting or anything special. The only thing I had to do was know where that data is located, what format it's in, and I can write T-SQL to do whatever I'd like. So let's talk JSON. See, I showed you CSV, and I kind of sneaky showed you Parquet. But JSON's a little different. See, there is no JSON format for Synapse. It actually uses the CSV format. And we have the outcome.json file. So I want to show you this because I'm going to rant about it. This is outcomes.json. Now, as I open this up, if you're familiar with JSON, I'm going to tell you that this is a list of data in JSON format, except I got one little problem. And one little problem is I'm missing my brackets. A JSON list requires square brackets at the beginning and end and commas between every one of these JSON objects. Now, the curly braces and the key value pairing of these, outcome ID to outcome name crop failure, that's perfectly valid JSON. But for this entire file to be valid JSON, it needs square bracket, and commas between each JSON object. However, if you use a properly formatted JSON file, the serverless SQL pool will not understand and it will choke. You have to use one JSON object per row and a new line between each. Kind of a mess. Not a big fan of that at all.
It'll choke on the brackets, Kevin?
Yep, it will fail
Oh.
to read this file if you have
Proper
proper
JSON. Okay.
JSON. So you have to write it. And it turns out actually you can write in T-SQL without JSON wrapper, I think is the syntax, without _JSON _wrapper. And they will create a file, or it'll create JSON like this without the square brackets or commas. But getting this from most things that emit JSON is actually kind of difficult. So not a great experience for reading JSON. But supposing that you do, you format as a CSV and you use this special combination of field terminator and field quote to read JSON. Then it'll give you a document in varchar max. And each row, technically this is a row in the document, and you can use JSON value to parse out outcome ID, outcome name. And I just showed doc for the sake of seeing what it looks like. So we can get this data out and it does work. It's just kind of nasty. And I can do this also with plots. This is a larger file. It's got one set of information for each plot. So in on Mars, you get 40 acres and a space mule. And we can see everybody's got roughly 40 acres. That's the first form, open row set. Let's talk about the second form, external tables with Polybase. Synapse extends a Microsoft technology for data virtualization called Polybase. Polybase lets you read from a lot of different data platform technologies. Actually, I have a whole talk on Polybase. I have a whole book on Polybase if you're really interested. Check out more info on Polybase, csmore.info/on/Polybase. I can copy that link and put it in chat if you're interested. That's a talk. I've got videos. I've got all kinds of stuff. Lots of blog posts. Got a lot on Polybase. For Azure Synapse Analytics, their version of Polybase is a special version that can only read from a data lake. So it's going to read from Azure Data Lake Storage Gen 2. There are three kinds of external objects. First, data sources. Second, file formats. Third, tables. We're going to need to understand all three of those to figure out Polybase. An external data source is basically a pointer to where the data lives. The data doesn't live in the serverless SQL pool. It lives in the data lake. So this is our pointer. It's to the data lake. On premises, I can use Polybase to read from, say, Oracle, from MongoDB, from other SQL Server instances, read from Azure Blob Storage, et cetera, et cetera. The data doesn't actually migrate over to SQL Server or to the serverless SQL pool. It stays in the external data source as its permanent storage. What we do is we retrieve that data on demand, process it, show it to the end user, and then dump it, because this isn't the home for that data. This is just a way station. So to create our data lake, we've got a couple of options, and I'm showing one option here to create an external data source with the location of my folder where that data is located. And in this case, I'm using a SAS token as a credential. How do I create that SAS token? Well, I create a database scoped credential. Identity equals shared access signature. Secret is a generated SAS token. And again, you may ask, wait, how do I create that SAS token? I'll show you in a little bit.
Yeah, I don't even know what that is. I can tell I'm lost.
A SAS token is a shared, basically, it stands for shared access signature. The idea is I'm going to give you access to folders in my data lake, but I'm going to limit what rights you have. I'm going to maybe say that you're allowed to read this folder or this container or just this file. I'm going to say that you're allowed to list all of the files in this directory, that you're allowed to read, write, delete. There are specific rights that you can grant. With SAS tokens, you can even go so far as to say, this token is only valid for 30 minutes or for 30 days or till the year 10,000. You can limit it by IP address. Only this IP address is allowed to use the SAS token. And if you're not querying from that IP address, it's going to fail.
Okay, that's helpful. Thanks.
And I can give that SAS token out to anybody. I can generate thousands of them without having to explicitly define permissions on accounts. So you can be a completely external user, get a token, and you use that token to query data from my data lake. And then when I'm done with you, I can expire that token, or I can have it expire automatically on a daily basis. And when I'm done, well, I just don't give you a new one. My little bit of a side note, by the way, on this is that there is another way of doing this, which is probably better, and it's called the managed identity, the managed service identity. And if you say identity equals managed service identity, you don't have a secret, and it's just created. This is an account that gets created with the Synapse workspace, and it has specific defined permissions. You would have to grant the Synapse account storage blob data contributor. I always get those words confused. It's storage blob data contributor or storage blob data owner. And that's going to grant the account the appropriate permissions to either read data, write data, or be able to handle any operations against that data lake. Then you don't have to generate new SAS tokens for end users. So a couple of different options that are available. Next up, external file format. This is my way of telling Polybase, this is the file format. This is CSV. This is Parquet. Orc is not actually supported in Azure Synapse Analytics for the serverless SQL pool. It is supported on premises or when querying Azure Blob Storage. Orc is another competitor of Parquet. It's another columnar style file format. It's just that it kind of lost the battle with Parquet. So Parquet has become the standard. Orc is the version that I liked. I tend to like the thing that loses. For example, I was a big fan of Mercurial, not so much of Git. See where that got me. If I want to create an external file format, let's say it's CSV. Well, my format type is delimited text. You can see already this is a bit different from Open Row Set where format equals CSV. Here, format type, delimited text. And I can specify format options. The field terminator is a comma. String delimiters are quotes. If I wanted to create one for Parquet, I can say format type equals Parquet. No single quotes around the name like we had for format in Open Row Set. And I have this other option called data compression. There are two data compression formats, one for Snappy and one gzip. And there is a minor difference between the two. One is a little bit more efficient in terms of CPU. The other is a little bit more efficient in terms of storage space. And it's very little. It's not enough for me to remember which is which, and Polybase will just work fine with both of them. So whichever compression format you use, no big deal. External tables. So we've told Polybase, here is where your data is. We've told it, here is the shape of the data in terms of file format. Now we're going to say, here is the structure of the data, because SQL Server craves structure. We need to know what are the data types, what are the data lengths, whether things are missing or not. We need to have it in a particular structure, and Polybase will reject records that do not fit that shape that you defined. External tables look a lot like regular tables. Just we have an extra word, external. So create external table. Plot ID, report date time, errorability score. You can see those look pretty much the same as otherwise. In this case, I actually don't specify nullability. I don't specify null or not null. It is going to allow null by default. And if I explicitly specify not null, I actually get an error. So everything's nullable, but that's okay because we're not inserting, we're not deleting, we're just taking as is. So we're going to accept it how it is. And then here's where things get a little weird. We have a with clause. We say, here is our data source, Mars Farming curated, that data lake. Here's our file format, Parquet file format. Here's our location, errorability score 2120-01. This is going to look for all errorability scores for January of 2120. And I talked through all that. Please don't think of Open Row Set versus Polybase as either or. It is a yes and. You can use Open Row Set for real easy spelunking. You can use Polybase for more structured, ordered versions of data. And you can create external tables pretty easily. So if I have a report that maybe runs once in a while, it can be slow. I could actually expose that using the Serverless Sql Pool, creating an external table with Polybase and having it be available to callers. Especially if my data doesn't fit the classic Kimball model, or if I don't have nearly enough to really make sense to use a dedicated SQL pool. So I could store that data in the data lake, make it available through the Serverless Sql Pool. Also, this gets me to the one exception, the little asterisk by you don't insert, update, delete, merge, truncate data in a Serverless Sql Pool, except when you create an external table as a select statement, CETAS. CETAS works a bit like this. We say create external table, just like before, but you can see this with clause. So it's going to be in my curated data source, in my errorability score 2116-01 folder in Parquet format. And we are going to write into that table the results of this select statement. So open row set, I'm going to read all of the raw data is CSV format, and it's coming from every star.txt, basically every file that's in that folder. And I'll specify plot ID, report date time, errorability score, and I'll put in a filter that says where the report date is 2116, the year, and the month is 1. So January of 2116. And incidentally, if you look at my curated folder, you may have noticed that there's a whole bunch of small Parquet files when I look in the curated folders. The reason for that is that's the output from that query. So I ran that for every month, querying all of my raw data, reshaping it by year, month, and storing in Parquet format for each measure. And that was my process. I basically did the entire ETL process using queries in the Serverless Sql Pool. So let's go back and look at some more demo stuff. I'm going to jump to this Polybase tables. Before I do that, I need to create external objects. Do I have a symmetric key? I probably do, but if I don't, I need to create one. So we need to have a master key for creation of database scope credentials. And then if I have a SAS token already, then I don't need a new one. And it turns out that I already have one. Let's double check and see, yep, I've got one. If I didn't, I would have one here. How do I create one? Kevin, you might be asking, because I really didn't show you how to create one. So if we right click on here, we can see some properties. And we can see this is the ABFSS path. This is kind of what we need to get to, but I can't create a SAS token from here. It turns out that I'm going to have to create it from the storage account in the portal, or I could use a tool like Azure Storage Explorer. I could use the Azure CLI, the command line. I could use Azure PowerShell. But let me pull up the data lake itself, the storage account in Azure. And good thing I've got it over here because my subscription hider isn't actually hiding the subscription today. So we're gonna go like that and say inside Synapse, inside Mars Farming Curated, I'm gonna right click and generate SAS token. That SAS token has specific rights. I'm basing it off of one of my keys. So also, if you have SAS tokens that get exposed to the broader internet and you don't want that, you can reset your key, and that's going to break every SAS token that's out there. We grant specific permissions on our token. We give it a start and an end time. So here by default, it's roughly 1 day. Or actually not even that, it's about 6 hours. And we can even allow specific IP addresses or IP ranges. We can force HTTPS only, which generally is something I would do. So we've got not too many options here, but enough that I can generate a SAS token. And you know what, let's say I generate that SAS token and I could copy this and I could give that to you and you'd be able to read from Mars Farming Curated for about 6 hours. Once you have that token, then if I close some of these, I could put that into the secret right here and create my database scoped credential. Then I can create a data source, Mars Farming Curated, that points to my data lake, Synapse Mars Farming Curated, using that SAS token. I can create the Parquet file format that I need. And once I've got all of that, we can create a table in Polybase. This table, sysexternal tables, errorability test 212001. So let's create that table and we can try it out. Just select top 10, like a regular SQL table. And it's going to give us results back. Going to be a little slow, but there we go. 11 seconds, and it gave us back some rows. We can, of course, filter. We can do most anything that you can do in a select statement. I can join to other tables. I can use outer apply, cross apply, common table expressions. I can use subqueries. I can filter. I can compute columns. It's just a regular table, basically. And we can see here all of the ones for plot 4462 for the day of March 1st, 2120, and the errorability scores really don't change very much.
So a quick question.
Yeah, go ahead.
If you go back to the data area, will you see that table name listed under serverless?
I should see it, and
okay.
I'm blanking on why I'm not seeing it. I'm sure that there's some dumb reason why I'm not actually seeing it in here. Oh,
okay.
There was a dumb reason why I wasn't seeing it. And I'll bet you it's because I didn't have any tables in that database at the time.
Okay. So now you do.
Yeah. Yeah. That's why I was looking here earlier, like, where's my database? Here it is. So here's my table. It's got columns. I could right click and say select top 100 rows. And it gives me my results.
Is that so today? Is that the only way you create external tables is through the Polybase?
Yes. So create external table is tied very closely with Polybase. There is another concept of external tables that's a little separate, but this is pretty much all Polybase. So we have our data, we have our database, we have our table. And incidentally, if you really hate this interface, you can use Management Studio. So you can connect to your serverless SQL pool, use your credentials, use Azure AD credentials, and connect to it. You could use Azure
very
Data
good to
Studio.
hear. I love Management Studio.
Yep, and so it's just going to work. It's going to look very similar to a regular database. You won't have all of the capabilities, but in the sense of, well, you're not going to be able to create new regular tables because Serverless SQL Pool doesn't support that. But you will have the ability to write your queries, open up a new query window, select things. You'll see the list of external tables that are there. You'll see certain management capabilities.
Actually, this is beautiful compared to the Snowflake interface. I shouldn't complain. This is much nicer.
And here's my create a polybase table where I was using CETAS. I'm not going to run this because this is actually pretty slow. It's probably about 10 plus minutes to run because it has to parse through all of that file and read. It's an incredibly inefficient way of doing it, but I had nothing better to do that night. So I actually put this in a loop and had it create one for every month and just let it run. So that is Polybase in a few minutes. Now let's talk about spelunking. My favorite term in this world of Serverless SQL Pool. Ad hoc data exploration. I have data in files. You don't get much more ad hoc than that. And I want to just query those files and understand what's in them and process them out a little bit. If you're familiar in the AWS world, this is like AWS Athena. This is in Athena, that's using HiveQL to query data in their S3 buckets. In the Azure world, you're using T-SQL to query data in a data lake. If you use Open Row Path, then, Open Row Set, then you can use file path searches because Open Row Set queries, generally, the easy mode is load data from a file. You know, we saw that already, errability score 1. So if I drill in on that, we can see I'm getting one single text file from one single location. But I can use asterisks, as we saw, and get a variety of files. So give me everything in errability score, in the children of errability score. If you use asterisk like this, by the way, it does not go recursively. If you drop the asterisk, it will actually go recursive. So errability score /star is everything in the direct folder. Errability score / is everything in the direct folder plus child folders. Let's say, though, I only want the ones that are errability score _star. So maybe I have other measures. I have CO2 level, O2 level, N2 level. Or I have errability score 1.txt, or maybe it's CSV, or maybe PRN because I've got old Windows print files. Whatever your 3-character ending is, you can say star, and as long as they're the same file format, if they're all comma delimited or semicolon delimited files, then no big deal. We're just going to pick them all up. A little bit further, there's a function called file path. There's a function called file name. These combined will give you some details on a file. And in this case, what I have is load my data from any folder, any Parquet file for January of 2120. I can use file name to give me the name of the file, and I can use count big, obviously gives me a number of stars of rows. Group it by file name. And if I run this, it's actually really fast because it's not actually parsing the Parquet file. If it was comma separated values, flat file text, then actually it would have to parse through the entire file. It would be pretty slow. With Parquet, though, I mentioned that there are headers. That header includes number of rows. So all it has to do is read the header and see, oh, there's 1,089,216 rows in that file, and then move on to the next file. I can also do this concurrently in parallel. which means I can have multiple processes working on those files at once and then sending their data to the mothership. I don't control that as a developer. I don't say go parallel or not. I don't say I want 8 levels of parallelism, like max stop. We don't really control that. This is internal. And so there's not a lot that I can do from a developer standpoint for efficiency in that regard. I just have to deal with what's there. Can be a downside. In addition to file.
Thank you, Kevin. I got to run. Sorry to interrupt.
Okay, well,
thank you.
Good seeing you, Elaine. So file path. File path is going to allow me to look at multiple asterisks, not just the name, but also different levels within the folder. So if I say file path 1, that is the first asterisk. File path 2, second asterisk. File path 3 or file name is that last one. So if I said year and month and number of rows, I don't have to look at any of the data because I know based on the folder that it's in, what the year is and what the month is. And if I group that, again, I can get all of that data summed up very quickly because I'm just reading the headers and understanding based off of my folder structure that the data should be in here. This does imply, by the way, that you have a process to make sure that the data is in the correct folder. If you put the data in the incorrect folder, you'll get the incorrect results. But if you do it right, you get results back real fast. And you can also use these in a where clause. So I could say where the file name is like C, starts with a C, and show me only the files, or show me only the months that have files that begin with C, and show me the count of all of the rows in those files. Not too bad. Again, didn't take much time at all. Didn't have to process any of the data in there, just the metadata in the headers. If I want to export, you can export from the UI using export results, and it can write out to CSV, JSON, or XML. Interestingly, cannot write out to a Parquet file. And there is some rudimentary charting that's available that I'm going to skip for time purposes. It's similar to what you get in Azure Data Studio, which means kind of works, except it's really limiting. So let's spelunk a little. Looking at file path, and I have my file name and count from 2120 January. If I run this query, then we're going to see that it took 1 second to do. It clearly wasn't reading all of the files. We saw that it was taking 10 seconds to read a file, so clearly wasn't doing that. I can get this information across all of my warehouse in the curated errorability scores and get year, month, file name, and then count of rows. So let's run that. Might take 4 seconds, 5 seconds. May take 6 because it's shy today. Synapse gets really shy when I present. If this were not sharing, I bet you it would have finished in 10 seconds. But I'm sharing, therefore it takes twice as long. Nonetheless, it still didn't read any of the file of the actual data. It just read the metadata, got the counts of rows. And if I ditch the file name, what we'll see is the results will be faster. Instead of taking 18 seconds, it should take about 4 seconds. But it's going to take 8 because twice as long. If we want to filter on file names, I had errorability.filename. I could also filter on file paths. I can filter on combinations of these without having to read files. But again, this is specifically for Parquet. If you start bringing in CSVs, it will have to read the data. So it will be a little bit slower that way. But if you use
those demos,
ahead,
would they work same results if you had Delta?
So if I was using Delta Lake, would I get the same types of results? Yes, I would still get these same results. The file names may be a little bit different. So I would probably focus on the folders instead of the file names themselves,
Okay.
but I would still get those same results because in there I'd have Parquet and JSON. And actually, I would say format equals Delta instead of Parquet.
Okay, great. Thank you.
All right. Talk a little bit about a logical data warehouse. I intimated this earlier, but let's make it explicit. Historically, we focused on physical data warehouses. The dedicated SQL pool is an implementation of a dedicated physical warehouse at large scale. But I can create logical data warehouses when that makes sense. Like, for example, if my data just isn't that large, then maybe I'll have a logical data warehouse. Databricks coined this term called the lake house. And the idea of the lake house is warehouse plus data lake, one managed area. This is their image. And what we get at is, let me zoom it here. I have, back in the 80s, we had this notion of data warehouses where we had data that would come in from different sources. We had ETL processes to store the data in your marts or in your enterprise data warehouse. That data would then become available to report users, would be available to business intelligence tooling. We have Kimball's data warehouse toolkit that's been around for decades. Really good, really mature practice for building warehouses. Over the last decade, we've had this notion of the data lake. The idea of the data lake is I can dump data in different formats. That could be structured data. It could be semi-structured data in a JSON format. It could be XML data. It could be unstructured data, videos, images, sound, audio. Unstructured in the sense that we're not going to be able to read that in a classic database. So we have a variety of different data sources, and we store data in this lake. Then we use ETL or ELT to build warehouses and report off of that. So our data warehouse sits on top of the data lake. This is kind of where you get to with the dedicated SQL pool. We can store all of our data, raw data in the data lake. We can process it. We can make it correct. We do all of our data cleaning, and then we can load it into the dedicated SQL pool for really good performance. But we may have other paths where data scientists query data from the data lake directly. They do their own data prep. They build out machine learning models. The lake house is a pretty new concept. And the idea here is, well, what if we just get rid of ETL? What if instead of having a warehouse as an intermediary, we just query the data lake directly? And it's an interesting what if scenario. It's kind of a little bit what we do with lake databases and with the serverless SQL pool. It's also a fantasy for any real company that wants to do true warehousing because it's going to be way too slow. 3 years from now, if you talk to me, I'm probably going to say, yeah, Lakehouse, it's a pretty cool idea. I think it's useful. I think it's ready. Today, I don't think it's ready. I think it's maturing. Databricks is putting a lot of effort into this. They've bet the farm on lakehouses. Microsoft is buying into this notion of lakehouses. So I think it is going to be a viable product. It's just not there for real warehousing. Nonetheless, it doesn't mean that we can't do anything with that notion. The serverless SQL pool, well, there's some similarities. I can create external tables and store the data in my data lake, query it from those external tables on demand. So let's take a quick look at what that might entail. What I have here are a variety of, in this case, views. So I've got a view for airability score. I've got one for CO2 level, nitrogen level. We've got one for oxygen. Got one for pH, temperature. We've got one for water for the 9,000 or so plots. And what if I wanted to write a query? So I select the top 5-star from water score. If I look at my Mars Farming SQL warehouse, if I reset that, I can look at these views, and I've got just a bunch of views, just like a regular SQL database. I could create those as well as external tables if I wished. It's just that for this purpose, I ended up using open row set and saying create a view as open row set. No difference in terms of core functionality. Minor difference in terms of permissions necessary. And I could write a query that joins all of these things together for a particular date and time. So let me run the query, and then we're going to talk about this nasty tail. So what I have, plot, join to errorability score on plot ID, join to CO2 level on plot ID, and report date and time. O2 level, plot ID, report date and time. Nitrogen level, pH level, temperature, water score. All of these things are joined together where the report date and time is 8 a.m. on March 15th of 2118. And then if I just had this query, if I stopped right here, this query would take forever to finish up. Even though it's only, I don't know, a few hundred rows, 5,000 rows or so in this case. What makes a difference is saying year 2118, month 3, year 2118, month 3. Because if I go back to the definitions of, let's say, water score, we have file path 1 as year, file path 2 as month. So year 2117, month is 3. So that way it goes directly to the correct folder instead of scanning the whole data set. If I don't include those years and months, if I don't include that file path, it's going to scan the whole data set because there's no constraint that says year 2118, month 3, that this report date time may only be in a folder /2118/3. Somebody may have goofed, put it in the wrong folder. We don't have constraints that mandate it. So therefore, we put in all of these clauses and it returns in 20 seconds instead of literally a couple hours, because it only scans a small amount of data instead of all of the data. So that is the idea of the logical data warehouse. And I could have these views just exist. And as people need the data, they can write their own ad hoc queries like it was a regular data warehouse. It's just going to be a little slow.
Question on the tables versus views. What's your been experience to determine which direction you go?
The agenda item 6, security.
Okay, thank you.
Yep. So actually, excellent question, because it's going to get us to this topic of security. The really short answer is Polybase has certain specific requirements if you need to create a table. If you need to view a table using the open row set, you have a different set of requirements. And if you need to read tables from Polybase, you have a third set of requirements. And so the serverless SQL pool, you're not going to have as much in the way of security options as on-prem SQL Server, because we don't insert, update, delete, merge, truncate data. But there are several ways that we can control access to data. And the easiest way to do that, we're going to grant access to those files or folders, generating a SAS token. So there I was in the storage account, you may recall, and I generated a SAS token. If I control the underlying data, I can have several tokens, some of them for the entirety of curated data, some of it just for errorability score, some of it just for certain folders. And then the serverless SQL pool allows me to do role-based security. So I can create database roles. Like here, I've got 3 database roles, and I can add members to roles, just like on premises. The concept of logins, the concept of users, the concept of roles, just exactly the same. The specific roles are a little bit different, but the concepts are the same. I can grant permissions, grant, revoke, deny. So here I'm granting select on an object to analysts, on a schema to analysts, references on a credential. This is what's going to allow me to read the credential without knowing what the secret is. I can't tell you what the secret is, but I can at least use that credential when I query a table in Polybase. Now, if I want to run open row set, I need to grant administer database bulk operations. On-prem, that sounds kind of scary. Wait, now you can bulk insert. But remember, in the serverless SQL pool, I can't insert. So there's no bulk insert because there's no regular insert. Administer database bulk operations basically is run open row set commands. So sounds scary, is not scary. If I need to create a external table using Polybase, I grant control. Oh, now we're talking scary. Grant control is basically you are an owner of the database. You can do pretty much anything you want on that database. I can set up permissions. I can create or destroy external tables, destroy views. I can query data via open row set. I can drop other users. I can do a lot of interesting stuff with control. So save that for power users, save that for automated processes to deploy out your external tables, and grant DB data reader or grant select on the tables and grant references to whatever credentials you need to get those data. Now, if you're interested in row level security, you may be familiar with that in SQL Server 2016 and later. Dedicated SQL pools have row level security. The serverless SQL pool technically doesn't, but you can fake it. What we can do is create a role like North Armstrong analysts. So these are people who can view data in one city. And we add a member. One person, you got it. And then we create a view that says DBO errorability queries from the entirety of all Parquet data, and then says, if you're me, then you get all of the data. If you're a North Armstrong person, you get that city. If you're a Dust Valley person, you get that city, etc. So this is a kind of hacky way of doing row level security on data in your serverless SQL pool. You could, of course, also create a function to determine whether or not a particular row is supported. So now I've got my city name that I send in, and here's my condition. You may look at this and say, that looks a lot like a security predicate in row level security for on-prem SQL Server. And you're right, it's extremely similar, but the use is a little different. Instead of creating a policy, we actually cross-apply that function to our errorability table or to our errorability view. And then people can query secure.errorability, and it's going to give them just their rows. I've said probably like 5 times, serverless SQL pool is slow. This is going to make it slower. There will be a performance impact here because you're querying all of the data to get to the records that are supported for you, that are available to you. There's no way for the optimizer to say, you're not going to have access to these rows in the file, so I'm just going to ignore them. You got to scan the whole thing. All right, let's talk about money. Very important topic. How much is this going to cost? I mean, I told you, $5 per terabyte processed. But what is a processed byte of data? What does that actually mean? See, the serverless SQL pool, that pricing model is quite a bit different from the dedicated pool and the Spark pool. Dedicated SQL pools, Spark pools, Data Explorer pools, those bill you based on existence. I have a dedicated SQL pool that is running. I'm getting charged X number of dollars per hour that it runs. Serverless SQL pool can run for months and not be billed until I run a query against it. Data processing is any data that you read from files, any metadata that you read from files, any data that you write to temp tables. any data that you write to eager spools, to lazy spools, data that you write to storage via CETAS, data that's transferred between the nodes that do your processing, data that's written out to the end user. All of that is considered data processed. So if I read a byte, if it's involved in an eager spool, it's written out to a temp table, it's read from the temp table, it's written out to storage and CETAS, it's queried from storage and CETAS, it's written out to the end user, that's like 7 or 8 bytes. So that 1 byte can be counted multiple times at different phases. Each query has a minimum cost of 10 megabytes of data processed. So if you query 2 rows like that outcome table, you're still going to get charged 10 megabytes. This is why the serverless SQL pool, we recommend that you not have a huge number of very, very small files. Have files that are large enough that querying them makes sense so that you don't get charged that 10 megabytes for your query when you read one file that was 100 bytes. If you read 5,000 files that are 11 megabytes, you get charged 11 megabytes. So it's not like 10 megabytes per file, it's 10 megabytes per query. So how do we save money here? Few ways. Number one, scan the minimum amount of data. That's kind of the, well, duh, of course, answer. Don't scan a folder if you don't care about the results in it. This was where my query, where I had all of those extra and clauses, not only is it faster, it saves money. This is an area where performance tuning and cost align so well that writing better queries saves the company money. And you can easily show the ROI of your T-SQL skills. But there are a few other things that we can do to shave a few dollars off, or maybe a lot of dollars. First, use the right file format. Parquet is typically superior to CSV for a few reasons. Number one, Parquet compresses data. If you have 100 megabytes of CSV that compresses down to 10 megabytes in Parquet, when I read that data, it's 10 megabytes of data. Number two, Parquet includes column metadata. So if I don't need to read that 10 megabytes, I don't have to read it. I only read the few dozen bytes of the header. If I do that for 10,000 files, maybe I have 8 megabytes, 10 megabytes, 12 megabytes, instead of all of the data cost. And with Parquet, you also only read the columns that you need. So I may have a 1 terabyte file, but if I just read a column that's an int, I might only be charged for half a gig because I just have that many records. So it's columnar. If you specify the columns, if you don't say star, you specify the columns and you don't have all of the columns in there, you're going to save money. Select star literally costs you money. This is actually a pretty cool system. But the downside, I mentioned compression, where it's 10 megabytes on disk, but it is returned back in result sets uncompressed. So your query reads in a 1 terabyte worth of file data. Let's say I have a file that's 1 terabyte. It's a Parquet file, big old chunky boy. And it is actually 5 terabytes of raw data that's been compressed down to 1 terabyte. The reading of that file, the processing of that file is 1 terabyte. If I select star from that file and I somehow get Management Studio or get the website to actually process this, some miracle happens, I just got 5 terabytes of data because that's the uncompressed written out size. Congratulations, that was $30. $5 per terabyte processed. Writing to a result set is included in that processing charge. So 6 terabytes of data processed, $30. By contrast, if I aggregate the data and I return 1 row, I read 1 terabyte, $5, plus 1 row, not even a cent. So $5 versus $30. Again, Write good queries, save money. Write bad queries, bankrupt the company. No pressure. Using file name and file path, we already saw, made that query faster, lets us focus in on specific folders, lets us focus in, narrow down our requests. This is where having things like year, month, day, hour, depending on the level of granularity of queries, can make a huge difference. Even when you're using open row set, also when you're using polybase, doesn't matter which of the two techniques you use. If you get the correct locations, the correct folder paths, then you can tell the serverless SQL pool, only go look here, and thereby not look anywhere else. Data that you don't process, you don't pay for. Now, let's suppose you have that 1 terabyte file and you frequently need to calculate the aggregates, and it's not header information, it's not metadata. What you could do, especially if you're willing to have slightly old data, you run that once, you write your query, and you write out those results to another file. That aggregated file, instead of being 1 terabyte, maybe it's 10 megabytes, maybe it's 5 megabytes. Now, every time you query that file, you get charged 10 megs instead of 1 terabyte. So instead of $5, it's a fraction of a cent. And so you get that one-time charge to incur the aggregation. And you'll get that one-time charge every time you perform the aggregation. But now I have potentially stale, but much cheaper data. So depending on how stale that data is allowed to be, pre-calculating aggregates can be a massive time saver in terms of query time, but also a money saver because you're not reprocessing over and over. Now, speaking of pre-processing, if you use CSV format, one thing that can happen is that as a way of trying to make performance better, the serverless SQL pool will prefetch some rows. So if I have 10 million rows in my CSV and I only need, say, the first 6 million, it may actually have prefetched another few 100,000 rows or a few thousand rows or whatever. You still pay for that prefetching. Even if it's not used as part of prefetching, you pay for that because it's processed data. Net effect tends to be pretty small, but if you run this enough times, maybe it adds up to a few cents, a couple bucks. If you use Parquet format, it will not do that. It doesn't need to prefetch rows because performance is generally going to be a lot faster to begin with. So again, Parquet format, generally the preference for data lakes. How much money, though, am I spending? And I can answer that using a DMV, sys.dm external data processed. So let's check that out. If I go here to financing, I can figure out how much money did I spend over the course of today, and select star from that DMV. And it's going to tell me that I've processed 846 megabytes today, about 900 megabytes this month. So that's how much it costs to run the queries that we ran through today. And if I figure out how much that was, not even a penny. So it did not cost me 1 cent to give this talk. In part because I used those filters. In part because this isn't a massive amount of data. I mean, we're talking probably, I think if I remember right, it's probably about 3 terabytes total of raw data and closer to 500 meg, closer to like, it's not even that much. It's probably measured in double-digit gigabytes in the curated. So not enormous data sets, but yeah, not too bad. So let's wrap things up. This has been a look at the serverless SQL pool in Azure Synapse Analytics. It is in the SQL Server family, but as you can see, it's quite a bit different from on-prem SQL Server. There are some assumptions that you can take with you. There are some other assumptions that I recommend checking at the door. If you want to learn more, if you'd like to grab slides, if you want to grab demos that I showed today, if you want to get links to additional resources, That's all at csmore.info/on/serverless. If you have any questions at all, please do feel free to reach out to me afterwards. Leave you an email address, and you can hit me up on Twitter for the rare occasion when I actually show up on Twitter. But with that, I want to say thank you for sticking it out, and everyone have a wonderful evening. If you have questions, I'll be here to take them. Otherwise, thank you.
Thank you, Kevin. Excellent. Enjoyed the session. Just let everybody know this has been recorded, and we'll have this on our YouTube channel in a few days with some other links we'll send out through Meetup as well that you see on the screen. So once again, thank you. Any last questions? Lan, do you have anything you want to ask? I'll take that as a no. Okay. Well, great. Thanks, Kevin. Good seeing you again. And
Likewise.
we will, we'll talk soon.
All
Okay.
right.
Thank you, sir. We'll see you.
Take care.
Bye.